Today's lesson is going to build on the prior lesson dealing with solution sets to equations and inequalities. So what we're going to focus on today is how do we represent the solution set to equations and inequalities. Now, I'm not going to spend a great deal of time on the do now because I just want to make the following point. If you were to substitute any of these numbers into the statement x over x equals 1, you will see that it's going to be true for all values except 0, because 0 divided by 0, or anything divided by 0, is undefined. So, what do we mean by solution set? The solution set is the set of all values of a variable that make an equation true. And I apologize for my handwriting, but that's as good as it gets. So, if we go back to the equation x over x equals 1, the solution set is all real numbers except 0. Now, as we do a lot of things in math, we do not like to come up with or describe our answers in words. We like to use math or shorthand notation. And what we're going to cover next in this table is how we translate an equation or inequality to a solution set in words, which is not necessarily desirable, but so that you can understand what that is, to a graph of it, which is very advantageous, or set notation, which is also very advantageous. So, going through the list, if I were to solve this equation, I get the answer is x equals 2. The solution in words is 2. On a number line, there's only one solution. Since 2 is a solution, I use a filled-in circle. Set notation, I need to use the braces. X is real. I'm telling people that x is a real number. Then I put this bar there because now I'm going to say it's real, but it's only the number 2. Okay? Sometimes you might see it written as this way also. Second example, again, I solve, and I get x is greater than or equal to 2. So, in words, it's all real numbers. Don't want to put an apostrophe there. So, all real numbers greater than or equal to 2. Very cumbersome way to do it. On the number line, I'm still going to have a filled-in circle because 2 is in the solution set. But now, since it's more than just 2, when it's greater, I go to the right with my arrow indicating that it's going to go on forever. Similar notation, x is real, except x is greater than or equal to 2. Continuing on, x plus 7 is greater than 9. Now I have x is greater than 2. So it's all real numbers greater than, hope it's spelled properly, I don't want to get Miss Tracy mad at me, than 2. Now the difference is 2 is not part of the solution set, so I put an open circle to the right, and very similar notation, except I do not have the equal to sign underneath. Okay? Continuing on with the chart, because if I'm going too fast, you can just pause it to get it. Again, I'm going to solve. I read this as x is less than or equal to 2. Please remember to read your inequalities from the variable, no matter which side it's on. So, in words, all real numbers less than or equal to 2. Filled in circle, less than, I'm going to go to the left, okay? Or you can see the direction of the inequality is pointing to the left. I'm going to the left. And x is real. X is less than or equal to 2. Okay? I know this gets to be a little bit tedious, but I want to make sure you see each of the potential scenarios. Again, all real numbers less than 2. Open circle to the left, and my set notation. X, sorry, that's not a nice looking X. X is less than 2. Okay, and then the last example, going back to what we did in the do now, x divided by x equals 1. Well, you saw from the words that we described our solution set, all real numbers except 0. Well, there's actually a very simple way to represent that on the number line. Open circle over 0, and my lines continuing in both directions. How do I write that in set notation? X is all real, but x cannot be 0. So you can see how the number line and set notation are very useful ways to represent the solution set. Now, a little bit more of an open-ended exercise. We want to fill in the other 3 columns based upon one of the columns' information. There is an infinite number of answers to this. So don't worry if what you have in your notes is different from what I'm going to put up here. So I'm going to work with the set of all real numbers less than or equal to 2. I could just write that as the very simple inequality x is less than or equal to 2. And here's my... Some of you may have created an equation, something like x plus 5 is less than or equal to 7. Doesn't matter, as long as it works out. X is all real numbers greater than 0. I can work my way backwards this way. It doesn't really matter. Set of real numbers greater than 0. And actually, I should put that in words as opposed to a symbol. It's Friday afternoon, so getting a little tired on this. And x is greater than 0. Okay. Now, if you look at your number line, here, you would read this as x is less than -1. So the set of real numbers less than -1, and in set notation, x is real, x is less than -1. Okay, so hopefully you're pretty comfortable with these examples. Let's go on to the next 3, because they're going to demonstrate some variations to what we've been doing. Now we have the equation x squared equals 9. Well, we worked on this before, and I don't want to go back through setting it equal to 0 using dots. We know the solution set is 3 and -3. So what's the solution set? The solution set is the real numbers, or the numbers 3 negative 3. How do I represent that on a number line? Very simple. Circled negative 3, circle 3. And how do I write that in set notation? X is real, X equals 3, and X equals negative 3. Okay? So now I have a finite number of solutions. That's how I would represent it on a number line. Usually not something you use a number line for, but you should be familiar with that. Now, if you look at number 11, you're going to see that when you work this out, and now my orientation's off a little bit, so I'm skewed here. You will see this is an identity statement. So what is my solution set? The set of all real numbers. How would you put that on a number line? Basically, it's your entire number line with arrows. And how would you write that? Just X is real. Without putting the bar afterwards, you're saying there's no limitation on what X can be. Okay. Now, to the last two examples. X squared is less than or equal to 9. Well, if you were to solve this, you'd see that X is less than or equal to 3, and X is less than or equal to negative 3. So, let me do the number line first, and then you'll see the words and the set notation. So, we know negative 3 is a solution and 3 is a solution. And since it's less than, if you were to choose any number between them, for example, 0, it makes it true. 2 makes it true. So, the set of real numbers between 3 and negative 3 inclusive. What the inclusive means is that 3 and negative 3 are part of the solution set. If I didn't have the equal to underneath, so that these would be open circles, then I would say between 3 and negative 3, and that would be it. Okay? How do I do set notation? X is real. Let me just make sure that that's an L and not the bar. So that X is greater than or equal to 3, less than or equal to, greater than or equal to negative 3, less than or equal to 3. Then finally, if you'll notice here, there's no solution. We call that the null or empty set. There's nothing to put on the number line. We put either an empty set or a 0 with the line through it. So, just to summarize what we covered today, we basically went through the ways to represent the solution set to an equation or an inequality, which are, we could do it in words, a number line, or we can do it with set notation, and you should be comfortable with all three of those methods.